All right, guys, so in this lesson, we're going to be talking about multiplying polynomials in terms of function notation. So today, the objective will be students will be able to multiply polynomials. We're going to talk specifically about binomials and trinomials. And we're going to be using function notation while we do that. So the objective for today is to multiply polynomials. That's the main thing. And then we're going to be focusing on binomials and trinomials and function notation. Okay? So the question for today and the steps that I will write for you on the right-hand side will be as a result of the question, which is how do we multiply functions with the box method? The box method is one way of multiplying polynomials. This is the way that I do it in my class, and the reason why I like to do this in my class is because it's more organized and doesn't allow you to forget terms. So I like using the box method. There are other methods for you to multiply polynomials, which we'll discuss at the end of the lesson. If you want to use that way, you can. But again, I like using the box method, so I'm going to teach it that way. All right. So these are the steps towards multiplying polynomials, and then we'll follow the steps to be able to complete the examples that I have for you. So step one, if you have a function or a couple of functions that you need to multiply, first you have to substitute the function. Second thing, we're going to need to draw the box. With appropriate dimensions, making sure that all of your terms will fit on the size of the box. You'll see what I mean in just a minute. Third is multiply and fill in box. Fourth step would be to write the first and the last term. The first one is located at the top left of the box. The last one is located at the bottom right. This will be part of your final answer. And finally, we need to combine like terms. And this is done typically diagonally for most problems. All right, so these are the steps. I will go ahead and do some examples for you. If you guys are familiar with biology, this is very similar to what you have done in biology before. In biology, when you guys are talking about genetics, and you're talking about recessive genes, and I'm not a biologist, by the way. You have like recessive genes, and you have what are the other ones called? The capital ones.
Dominant.
Dominant. Thank you. See, I'm obviously not biologist. Don't tell Mr. Soto that I said that. You have dominant genes and recessive genes, and usually you draw a box to be able to fill that in. That is exactly what we're doing here, but we're doing it for the purpose of multiplying polynomials. So let's do an example. So example number one. Let me put that over here so it's neater. We're going to have two functions. First one is going to be f of x. You know what? So we're going to find f of x multiplied by g of x. And then I'll give you the f of x and g of x in a bit. It'll be easier that way because this one doesn't have any mathematical functions that are easily available. So find f of x multiplied with g of x. And then I need to give you those functions. So f of x is going to be equal to 2x plus 3. And g of x will be equal to 7x plus 7. So right here we have a binomial, which is f of x. Remember, binomial means two terms. Multiplied by a binomial, which is another two terms. So the first thing we need to do is substitute a function, right? Meaning like if we have f of x times g of x, it's actually equal to just 2x plus 3 multiplied with 7x plus 7, which means that we have a two terms multiplied by two terms. For that, I need to draw a box. And I need to make sure that within this box, I have enough spaces for two terms on one side and two terms on the other side. So it's going to be a 2 by 2 box. All right, so I'm going to make this box. I'm going to make 2 spaces by 2 spaces, which means that we're going to have a 2 by 2 box. On one side of the box, I will have my first two terms. I'm going to write 2x plus 3. On the other side of the box, I will have my next two terms. Again, the order doesn't matter, and I'll show you guys in just a second. 7x plus 7 will be the next term. Once you have the corresponding sides of the box, you're going to multiply to figure out what's going to be on the inside of the box. Okay, so what does that mean? So we need to multiply it in, kind of like we did when we when you guys did when you talked about Punnett squares, right? For genetics. So we have 7 times 2, which is 14. X times x will give me x to the power of 2. Then we do the same thing here. 7x times 3 will give me 21x. Don't forget the x, right? Then I line up the first column and the second row. 2 times 7 will give me 14, but I need an x there, so this will be 14x. Then I do the last column, last row, so I have 7 multiplied by 3, which is 21. All right, so basically we substituted the function, so that was done. Draw the box with appropriate dimensions. That was a 2 by 2 box, so we did that. Step 3 was multiply and fill in each square of the box. We did that by multiplying and filling out each square, right? So according to the rows and the columns multiplication. And then finally, step 4 is write the answer. So the final answer would be, first we need to write the top left term and the bottom right term as part of our answer. That would be this term right here. And the last term, which is this term right here, I'm going to fill those in as 14x squared. The last one was 21, and that was positive, so I'm going to put a plus 21. The only thing is that we're missing the middle term to be able to figure this out, and for that, we need to combine like terms. So to be able to do that, I need to do the combination of the 21x with the 14x. So what we do here is we're basically combining like terms, but I like calling it adding the peanut up because it looks like a peanut when you actually draw it. So if you add the peanut or the diagonal together, you get 14x plus 21x, which gives you 20, 30, 35, right? So this is positive 35x. So that middle term came from the addition of the peanut or the diagonal. All right. Once you have this, you have officially multiplied these two binomials together, and your final answer will be a polynomial or a trinomial, right? 14x squared plus 35x plus 21. So this is a second degree trinomial. All right, that's your first example. Any questions on the first example? All right, I have 5 total for you, and then we'll call it a day for the period. So second example, we have to multiply these next two polynomials, or I should say binomials, because I have another set of binomials for this. So we're going to have, for example 2, multiply k of x with rx. And I have to give you those functions right now. So let's say that k of x is equal to the function 5x plus 8. The function rx is equal to 6x minus 3. And we need to multiply those two together, right? So obviously we need to substitute this into the corresponding equation. We need to multiply the k times the r. And let's see what that actually gives me. So that means we're going to multiply 5x plus 8 multiplied with 6x minus 3. So binomial multiplied by a binomial, we should already know that that gives us a trinomial. Let's see what trinomial that'll give me. So next thing we need to do is draw a box that's appropriate to the 2 by 2, right? So we have 2 terms by 2 terms, so we should have a 2 by 2 box. So let's make a box. Oops, let's put it, there we go. Close enough to the corner so I can fit all of my terms. Next thing, I need to make the divisions. So there's 2 on one side, 2 on the other side. And then you need to write the terms on each side. So 5x plus 8, 6x minus 3. It doesn't matter which one you write first on one side or which one you write on the other side. On the first example, I wrote 2x plus 3, the first one on top. And the second one, I wrote it on the left side. Let's switch it up on this one. It doesn't matter. You'll get the same answer, I promise. If you switch it up, let me write on the top one, I'm going to write the 6x minus 3 now. And on the left side, I'm going to write the 5x plus 8. So again, doesn't matter which side you put it on, just pick. It's 2 by 2, so it'll work out. Once you have this, next thing we need to do is multiply everything out and fill in the boxes, right? So don't forget, when you multiply an x times an x, you get x to the power of 2, right? So 1 plus 1 gives me 2. So this will give me 5 times 6, which is 30. So this will be 30x to the power of 2. Don't forget the square, common mistake. 5x multiplied by negative 3 would go in this space. 5 times 3 is 15. We have a negative, so it'll be negative 15x. 6 times 8 will give me 48. We have to put the answer here. And then that 6 had an x, so it's going to be 48x. And then finally, negative 3 times 8. 8 times 3 is 24. We have a negative, so it's going to be negative 24. All right, so the first couple of steps are done. We substituted, drew a box, multiplied, and filled in the box. Next thing we need to do is write the first term and the last term, and then combine like terms. So the first term that I have here would be the top left corner, always. That first term is equal to 30x squared. That's not going to change, so we're going to write that as our first term. The last term in this example is the bottom right, which is the negative 24. We're going to write that as the last term. That's not going to change because there's nothing to be combined with that. Oops, that should be a 30. And then negative 24. The one thing that does change is the middle section, which is a result of the combining like terms, right? So we add the peanut together. So the diagonal, the 48x is going to be combined with the negative 15x. If I take 48 and subtract 15, calculator work, 33. So we get 33 positive x as my combination of those two like terms. So this should be plus 33x minus 24. So this will be my final answer. When I multiply those two functions together, 5x plus 8 multiplied by 6x minus 3, we get 30x squared plus 33x minus 24. All right. So far so good. Okay, let's kick it up a notch. Example 3. What if they don't give us a binomial multiplied by a binomial? What if they give us a binomial multiplied by a trinomial? What happens then? So in this example, we're going to have a binomial multiplied by a trinomial. We're going to call those h of x and k of x. So h of x, oops, sorry, h of x is going to be equal to the binomial 6x minus 4, k of x is going to be equal to 7x to the power of 2 plus x minus 4. So what do we do then? This time we have a binomial, which is two terms, right? That would be the h of x, multiplied by a trinomial, which is three terms. So the only thing that's going to change in this situation is the size of your box. All the other steps pretty much stay the same, with the exception of the last one, and we'll talk about that in just a second. All right, so as the steps suggest, first thing we need to do is substitute into the corresponding equation. Here, for example 3, they want us to multiply the h of x with the k of x, and the k of x is a little bit longer than the last example, right? Which means we need to multiply the 6x minus 4 with the 7x squared plus x minus 4. All right, so h of x multiplied with k of x. For that, we need to draw a box. The only difference between this and the last example is that the dimensions of the box are going to be a little bit different. Notice that I'm drawing it a little bit wider this time. That's because we have two terms on one side. So I'm going to make this division right here for my two terms. And then I have three terms on the other side. So I'm going to make two divisions here to fit my three terms. Come on, Cami, don't fail me now. So on the left side, I'm going to have the two terms, 6x minus 4. On the top, I'm going to have my three terms, which is 7x squared, positive x, minus 4. Now, in this example, of course, it does matter what goes where. On the last example, I said it doesn't matter what you put where. You can put the 6x minus 3 on the top, or you can put the 6x minus 3 on the side. It doesn't really matter because it's a 2 by 2 box. For this one, it does matter because we have a 3 by 2 box, which means that the three terms have to go on the section where it has 3 rows or 3 columns. All right, so just keep that in mind when you're drawing your box. So let's multiply everything out. The next steps will be the same, but we have more multiplying to do. So if we multiply these two out, I get 6 times 7, which is 42. I have two x's and then one more x, so I actually have x to the power of 3 as my final answer when I multiply it out. If I do the next column, I have 6x times x, so now I have 6x to the power of 2. If I do the next one, I have 6x multiplied by negative 4, so I have a negative 24x. Don't forget the x. That was along with the 6. Let's do the next row. So we have 7x squared times negative 4. 7 times 4 is 28, so we get negative 28x squared. Negative 4 times x is negative 4x. And then negative 4 times negative 4 is equal to positive 16. Don't forget the little plus. All right, so the next steps are the same. The only thing that's going to change is the last step. So the first term is still the top left corner, 42x to the power of 3. The last term is still the bottom right corner, which is positive 16. I'm going to go ahead and pencil those into where my answer is going to go. So this is going to be here, and this is going to be here, which is the last term. The only thing that's going to change now is that we don't have one diagonal anymore. We actually have two diagonals, or two peanuts. If you notice here, the last step is basically combine like terms, typically diagonally. It could be more than a couple of terms that you can combine together, and that's okay. In this particular example, as you can see, the like terms that I have the 28x squared, which can be combined with the 6x squared diagonally. So there's one peanut. But I also have another combination here, which is negative 4x that can be combined with the negative 24x, again diagonally. So they don't necessarily have to be diagonal every single time, but in this particular example, or in most examples you're going to do, it'll typically be diagonally. So we're combining like terms here. All right, so put it all together. Then now you're going to have 4 terms as your final answer. So once we combine these two like terms, that answer is going to go there. Once we combine these two like terms, that answer is going to go there. So we're going to get a quatrinomial, or a polynomial of degree, or a 4-term polynomial as our final answer. All right, the middle one will be negative 22 x squared from the first peanut. And the next one will be negative 24 plus negative 4, which gives me negative 28 x. Now, very important, notice that the variable does not change here, right? So here I had x, here I had x, my answer has x. We're not multiplying here, we're combining like terms. So the x does not change, right? Same thing with the x squared. Here we have x squared, here we have x squared. The x squared is still in the answer. Why? Because all we're doing is combining like terms. Adding and subtracting, you're not changing anything, right? So this is not multiplication with the peanut, we're just combining like terms, adding and subtracting. Okay, so that's it. Our final answer is this quaternomial, 42x to the power of 3 minus 22x squared plus, or sorry, minus 28x plus 16. All right. So the follow-up question or follow-up answer or thing that we're going to be going over is, okay, let's go into the situation in which we're going to have a 3 by 3 polynomial. So what would happen if we multiply 3 terms by 3 terms? How would that look? So that'll be the next example. So example number 4, let's say we have 2 functions or 2 polynomials written in function notation. Let's go back to f of x and g of x. I'll give you guys the functions right now. So for example number 4, f of x is going to be equal to the trinomial of x squared plus 2x plus 4. G of x is going to be another trinomial, which is negative 2x squared plus 5x minus 3. So we have these two polynomials of degree 2, or I should say second degree trinomials. It's another name for them. And we have f of x and g of x. So now we need to multiply these out. So again, the only thing that changes for these particular problems is the size of the box, right? So everything else will stay the same. The process is the same. So first number that I need to multiply is the x squared plus 2x plus 4. And I need to multiply that with the negative 2x squared plus 5x minus 3. So it's a trinomial, 3 terms, multiplied by another trinomial, 3 terms. So how many squares are we going to need in the box if you just do the mental math? So this box is going to be much, much bigger now, right? We're going to have 3 spaces on vertically to be able to fit those 3 terms. We're going to have 3 spaces horizontally to be able to fit those other 3 terms. Sorry if it's not even. And then we need to multiply the box out. Does it matter what goes where? Not really, because in this particular situation, kind of like the 2 by 2, we have the same number of terms, right? So I can put the x squared, back to drawing mode. I can put the x squared plus 2x plus 4 here, and then write down the other one on this side, negative 2x squared plus 5x minus 3. Or I can do it the other way. It doesn't really make a difference. You'll still get the same answer. You can write x squared plus 2x plus 4 on the left side. And you can write negative 2x squared plus 5x minus 3 on top. Doesn't really matter, you'll get the same answer. All right, I'm going to leave it as this and multiply this out. So let's fill in the box now. So negative 2x squared times x squared, we get negative 2x to the power of 4. We add up the powers, right, because we're multiplying. 5x times x squared, we have 3 x's in total, so we get 5x to the power of 3. Negative 3 times x squared will give you just that, negative 3 times x squared, or negative 3x squared. Negative 2x to the power of 2 times 2x, we multiply this out, we get negative 4x to the power of 3. Move on to the next column and row. So we have 2x times 5x, we get a total of 10x to the power of 2. Next, we have negative 3 times 2x, we get negative 6x, right? Negative 6 times x. Next, final row, I have negative 2x squared times 4. We get negative 8x squared. Middle column, 5x times 4. 5 times 4 is 20, so we get 20x to the power, sorry, just x. And then finally, negative 3 times 4 is 12, so negative 12. All right. The next steps are the same, like I mentioned in the past. So we have our first term, which is always going to be the top left corner of your box. Our last term is the bottom right corner of your box. And the rest, we have to combine like terms. All right, so let me write this out. So the first one will be negative 2x to the power of 4. That is my first term. The last term will be the negative 12. The question is, what goes in the middle? So the answer to that question corresponds to how many peanuts are we going to have in this box now. So if we count, we actually have one diagonal that we can combine these like terms. Notice that they both have x to the power of 3, so we can actually combine these two, right? They both have x to the power of 3 within them. The next one that I can combine are the middle terms. So these all share x squared between all the terms, right? So we can basically combine the peanut for the negative 8, the 10, and the negative 3. And then finally, the other terms that can be combined are the 20x with the negative 6x. So we're going to have three terms that are going to go in between the negative 2x to the power of 4 and the negative 12. What are those terms? Well, that depends on what it is that we get when we actually combine them. All right, so the first one's going to go here. The second one is going to go here. And the last one, which I colored orange, is going to go here. Let's combine the first two. So we have negative 4x to the power of 3 plus 5. We get just 1. 5 minus 4 is 1, so it's 1x to the power of 3. Okay, the next one I have 10 minus 3 and then minus 8. Or in other words, 10 minus 11, because 8 plus 3 is 11. So we get a total of negative 1. So we get negative 1 x to the power of 2. And the final term that I get here is 20 minus 6, which we get 14. And they both had x's, so we get positive 14x. So my final answer is just that. You can leave it as is, or you can simplify it and make it write it neater in terms of like not writing the ones in front of the x's, because typically in math books you don't see that. So the final answer will look something like this: negative 2x to the power of 4 plus x cubed minus x squared plus 14x minus 12. So when you multiply a trinomial times a trinomial, you get 1, 2, 3, 4, 5 terms. So you get a pentanomial. But again, mathematicians are lazy, so anything above 3, they just call it a polynomial and call it a day. All right, so hopefully that makes sense in terms of the first 4 examples. Again, I will have this video available to you if you guys get confused or want to watch it all over again. I'm going to leave you with one last example, and this example is going to be special case. So basically a special case. So example 5. Before I write the example, I'm going to write what's wrong with this example and why is it a special case. So the question is, what do we do when there are no like terms I just say no or few. Sometimes there could be some like terms, but not others. And that basically is going to be what example 5 will be all about. So example 5, we're going to multiply g of x and k of x. All right, so for g of x, we're going to have 8x minus 3x to the power of 4 plus 10x squared. I heard a beep. Was there a question? Oh, no, guess not. Sorry. So g of x is 8x minus 3x to the power of 4 plus 10x squared. K of x is going to be another trinomial, negative 6x to the power of 4 minus 3x minus 8x to the power of 5. Okay, so we have three terms. So we have a trinomial multiplied with a trinomial, but this is going to be a little bit of a special case. You'll see why in just a second. Then we'll talk about why it didn't work out the way that it would normally work out with all the other examples that we did. All right, so these are my two trinomials. So we're going to draw a box. It's going to be a 3 by 3 box for us to be able to multiply this. So let's make that nice and big because this is our last example anyway, so no need to save space. Oops. Okay, if we write this out, we're going to get 8x minus 3x to the power of 4 plus 10x squared on one side, and then negative 6x to the power of 4 minus 3x minus 8x to the power of 5. Let's multiply this out and see what we get. 6 times 8 is 48, so we get negative 48x to the power of 5. 6 times 3 is 18, so we get 18x to the power of 8 when we add the 4 and the 4. Next one, we get negative 60 x to the power of 6 when we add the x's. For the next row, we're going to get negative 24, and then we have two x's, so x squared. For the next one, we get negative 3 times negative 3, which is positive 9. So it's 9x to the power of 5 because we have 5 x's total. The next one, we get 10x squared times 3, which is negative 30. X to the power of 3, 3x's total, right? Let's do the last row. 8 times 8 is 64, so we get negative 64, x to the power of 6. 8 times 3 is 24, so we get positive 24, x to the power of 9 after we add the x's. And then finally, we get 8 times 10, which is 80. And then we have a total of 7 x's. And then that 8 was a negative, so we get negative 80, x to the power of 7. Okay, now let's combine like terms. Now, most students, once they get good at this, they start getting like, okay, so I need to combine the like terms here, and typically the diagonal here and the diagonal there. The problem is that you're not going to necessarily get everything in order every single time. As you can see, my polynomial is not given to me in order from high degree to low degree. So this is not technically simplified, so it's not given to me from high degree to low degree, right? So for that reason, our diagonals are not neatly organized. So we cannot really combine like terms willy-nilly like this. As you can see, the power of 8 does not combine. X to the power of 8 does not combine with x to the power of 2. They're not the same power, so obviously you can't combine them. On this next peanut, we have x to the power of 6, x to the power of 5, x to the power of 6. We can't combine all those. We can combine the 6's only. The next one, we have x to the power of 9 and x to the power of 3. So every now and then you cannot combine in terms of like diagonally. That's okay because they're not going to give it to you in order every single time. But all you need to know is that if it's combining like terms, that's essentially all that we're doing here. So we look to all the terms that can be combined. The only ones that can be combined in this example are the x to the power of 5 and x to the power of 6 that we have here. So x to the power of 5 happens to be these two terms. X to the power of 6 happen to be these two terms. Nothing else can be combined. And if it can be combined, it's not a big deal. All we have to do is rewrite it and call it a day. All right, so don't overthink it. So as you can see, the biggest exponent that I have here is actually x to the power of 8. So the first term I should write is 18x to the power of 8. This one defies the rule, right? The next greatest power will be x to the power of 7. So I'm going to write negative 80 x to the power of 7. Oops, forgot the 0. The next lowest power that I have are the 6's, which I can combine. Negative 60 minus 64. I get negative 124. So we get negative 124 x to the power of 6. That came from the combination of the x to the power of 6, of course. The next one that I could do is the x to the power of 5, which I can combine the negative 48 with the positive 9. We get negative 39, right? So negative 39, x to the power of 5. Oops. I can keep going to all my other ones. The good thing about the other ones is that nothing else can be combined, so I can just write down the lowest power after that um, in sequence. Oops, I forgot one, didn't I? So I skipped the 24x to the power of 9. That should be the highest power, so that should go first. So we should start with that, right? 24x to the power of 9. And then the next one should be the 18x to the power of 8. Lower than 5, we have 3. So negative 30x to the power of 3. And then lower than that, we have 2. So finally, minus 24x to the power of 2. So this will be my final answer, and it looks ugly, and it looks long, and it looks complicated, but that's not the point. The point is, every now and then, if they don't give you, all you're doing inside the box is combining like terms. So if the polynomial is not organized and the peanut does not combine like terms diagonally, then you may have to just combine like terms like sporadically, depending on what you see that can be combined. Okay, that's pretty much what we're doing here, but I promise that the problems that I will give you for practice will be basically kind of like the first couple of examples.